Okay, welcome to day 7 of the stats program. This video I'm going to try something a little bit different where I'm going to go through the whole paper, all 7 questions, but I'm not going to do all the steps on the working. I'm just going to basically give a bit of a review of how you would solve each question, as just maybe a bit of an insight into maybe how I would approach them from a problem solving point of view. I won't do all the calculations and stuff because you can see that in the schedule. So we'll see how this goes. Okay, so question 1 is one of these questions that involves using the formulas for standard deviation and for the mean to find out other standard deviations and so forth. The important thing when you first look at this formula here is that this is just a fancy way of doing the sum of x, and this is just a fancy way of doing the sum of x squared. All that minus c is telling you is that each value, all these values, x1, x2, x3, all of them, they've taken c away from all of them before adding them up, okay? But it is just sum of x and sum of x squared. And you know that you can see those in the formula. So then when it asks you for the standard deviation, you know the standard deviation, no matter whether you add or subtract a constant value, the standard deviation will still be the same. So remember, for example, if you've got a dot plot, that's not a very good dot plot, and let's say the mean is 3, if you add 2 to all those values, all that will happen is that the whole dot plot will just move up by 2, but the standard deviation will still be the same. So in this case here, it makes no difference that minus c is there for us to work out the standard deviation. We can still go ahead, work out the mean using the sum of x, the standard deviation using the sum of x squared. So it's all good. And then for part 2, they're telling us now what the mean is without taking away c. So then all we have to do is compare the mean of what we've worked out for part 1 to this mean to work out how far apart they are, and that'll be our c value. Okay, so it's pretty straightforward. Yeah, and part 2, move that up there. This is talking about the probability of a birthday being equally likely, so on any day of the week, so there'd be a probability of 1/7. And we've got 7 days, and we're looking at out of 350 people, at least 47 had their birthday on a Monday. So it's a binomial question where you're saying, is their birthday on the Monday or not? And you've got a fixed number of trials, which is 350, but because the numbers are so big, you do an approximation. And the key thing there for your approximation is just to know what n the p is, because that will be your mean, and to use the root of npq, because that will be your standard deviation, which is all good. What else? To make sure that you look at what the continuity correction is. So in this case here, we want at least 47 people. So at least 47, which means that we would be going for here anything from 46.5 and above for our normal distribution when we do that approximation. Yeah, so just for completeness, the n would be 350 and the p in this case would be 1/7. Okay, so you go ahead, find the z-score, work out the probability, z-score, and so on, and solve that problem. And that would be a pretty nice 5 marks right there. Cool. Okay, and on to question 3, which is a semi-left graph. There's no real issues with this question. I think you guys are all good with it. Just remember to check the key here. So 203, for example, would be 20,300. Like that's got here, and just make sure that you give your answer in that same unit, so with the dollar sign and the same transformation. And for your Boltzmann plot here for part 2, just make sure that you draw that really nicely with a scale, label your scale, label the axes, all that kind of stuff, make it really nice and neat. For question 4, for part A, they're just trying to freak you out because there's no numbers in there, and at first you think, oh, what do I do? But the trick in this question here is that they tell you that the mean is positive. So what you can do is you can do a quick sketch for yourself. You know the mean is there, and you know that with a normal distribution that, roughly speaking, one standard deviation either side of the mean is 68%. In which case here, each standard deviation is worth half of mu. So if you were going to go 2 standard deviations either side of the mean, that would be half of mu plus half of mu, so a whole mu. So basically you would get down to 0 after 2 standard deviations, and everything below that would be negative. Okay, so from there, you know that you're looking at 2 standard deviations away or below the mean, which means your z-score is just -2. Okay, and then you can use that value to look it up and find out the probability. And then for part B, rice, yay. So they're normally distributed, which is all good. They tell you that they've got this random sample, and they found in that 253 weight over 2.1 grams. So all they're trying to do is make you do a little tiny bit of maths, which is basically to turn that into a percentage. So what percentage weighed over 22.1 kilograms? And then it just becomes an inverse normal question. Once you know here on your little picture how much weighed over 2.1 kilograms there, shaded out, you know, whatever 253 divided by 8,000 is whatever this is, you know, and then you're going to have to look up this area, the other side of it, on the inside the table to find the z-score, and then work backwards from that to find out the value of the standard deviation. Okay, and then question 5, she's producing these random integers between 7 and 21. And the random variable is the number of these integers which are multiples of 5. So you're looking at a binomial distribution here. First of all, you're going to think, how many of those, what's the probability, of an integer between 7 and 21 being 5? So you go through and count up how many there are out of those numbers, and you get, 20% of them are multiples of 5, and you've got 12 integers, so that's your n value. So when they say state distribution of x and give its parameters, if I was like how I would do it would be to say, it's binomial distribution, n equals 12 and p equals 0.2. But Cambridge kind of wants you to use this formal notation, which is, it goes like this. So you say the random variable x is distributed. So use little, that didn't come out very well, sorry. Is distributed, so use a little ampersand like that, I think it's called. By the binomial distribution. I use a capital B for that, and then what goes in the brackets are the n and the p value, and that's the notation that you'd use to describe the distribution and its parameters. For part 2, you just got to use the binomial distribution to work out 3 to 5 inclusive, so 3, probability of 3 plus probability of 4 plus probability of 5, and then for part 3, you don't know how many integers that she's producing between 7 and 21, but you know the probability that x equals 0, so none of them, is less than 0.01. So what you're going to do there is set up an equation. So 0.2 to the power of n, 0.8 to the power of n, because 0.8 is not getting a multiple of 5. Which is what you want, n times, for none of the integers to be multiples of 5. So you would just set up an equation. So 0.8 to the power of n has got to be less than 0.01. And you'd solve that using logs. We use log both sides, and then you get n log of 0.8 and so on to solve that one. So that's all good. If you're really against logs, you probably could just do some trial and error and still get the answer as well. Cool, so for question 6, lots of numbers, lots of people, it must be perms and coms. And it is kind of, so the first thing is to work out whether it's a perm or com. And then in this case here, we're looking at the order that they can go through a turnstile, so we're definitely arranging that order. So it's going to be a permutation type question. And then you just have a look at what they've given you. So this one's about people, so all the people are different, which is cool. So there's no need you have to divide through by duplicate letters like those ones. These are all different people. So yeah, for part 1, you're going to use a grouping approach. So you're going to first of all look at all the different ways you can arrange the 4 groups or families, and then you're going to look at how many ways within each group you can arrange the people themselves to go through a turnstile and multiply all that together. For part 2, obviously you have to take into account the fact that 2 adults can't go consecutively. So I would definitely have a go at trying to lay out what that looks like. So draw yourself up 14 spaces and try and have a go at drawing out kind of the situation And then from that, you should be able to start to generalise the kind of calculations that'll go into working out the answer. For part 3, the key thing here is you're now switching into a combination idea, in that you've got these 3 different roller coasters that you've got to put the 8 people into. And yeah, each combination that goes into each of the cars, you can work that out, and then you can just multiply them all to get the overall different ways that you can divide them up. Okay, so I'm not too sure if my kind of really quick review really helps with the perms and common ones, because I think those ones are best done with actually showing examples and that kind of stuff. So I will make another video for question 6 so you can see more clearly how to solve that one. Okay, so last question in this paper is question 7. And you just have to be careful to read the beginning part here. So it talks about these 2 boxes, and they take a ball out of box A and place it onto box B. So here, you don't know how many yellow balls there are, but however many yellow balls there are, plus the 5 white balls you originally had, plus 1 more that comes from box A, is going to make 6 balls. So it's going to be the total number of balls in that box. Yeah, so that's, and then of course X of them are yellow, so that's just your probabilities. It's all good. Part 2 is just copying it all out, just making sure you put 8/10 for the white ball and 2/10 for the yellow ball and so forth, and following the same logic through for here. So there's going to be X's involved for each of those branches as well. Then they tell you something so that you can basically set up an algebra equation and solve it for part 3. So if the ball from A is white, so you know it's white. So it's not so this is a conditional kind of statement. So you're starting here. Then the probability that this one's also white is 1/3. So you can add that on there, and then you can use that to work out actually what that probability is, which is fine. Sorry, how many yellow balls there are, because this plus this have to add to 1 on the same branch, right? So you can set up that equation and solve it. And then for part 4, it's a conditional probability question. So you know the deal. You go through and work out the probability of getting a yellow ball as your denominator, and then for the numerator, it's the intersection of the 2 events. In this case here, the probability that both box A and box B as yellow balls will be on the top. And you're done.